Okay, hi guys. We're going to get started with tonight's webinar. So tonight we're going to be talking about inheritance. So hopefully you guys have gone over inheritance in your classes by now, since the AP test is, I think, 2 or 3 weeks away now. Is this a topic that you guys have gone over? Do you guys feel like you have a good understanding of it, or are you a little bit confused? Because I remember when I took the AP class, inheritance was definitely a very tricky topic at first. So feel free to type in the chat or use your mic if you have one. Okay, great. So yeah, inheritance is definitely one of the harder topics on the AP test. For a lot of people, I'd say it's probably the hardest topic. So hopefully tonight I can help to answer some of your guys' questions on it. Okay, so first we're going to go over a PowerPoint about inheritance. Can you guys see my screen? Okay, great. Okay. So when we talk about inheritance, we are talking about the relationship between parent and child classes. And so basically in Java, you can have a class that inherits all the properties from another class. And when we have this, we have a relationship where you have a superclass or a parent class, which has all of the methods and the attributes that are going to be inherited by a child class or subclass that can then build onto those parent attributes. And so this is also known as an is-a relationship. And so this is a very easy way to check kind of conceptually if you should be using inheritance by saying that, as you can see from the examples down here, if we had a car class and a vehicle class, you can tell very easily that if you were to code these two classes in Java, it might make sense to do it through using a parent and subclass, because a car is a vehicle. Or with a dog and an animal, a dog is an animal. So this is a little bit different from using interfaces, which we talked about last week, where when you use inheritance, you have a has a relationship, versus using inheritance, you have a is a relationship. So hopefully that's kind of a conceptual way that you can view the difference between those two things. Does anybody have any questions so far? And if you don't have any questions, it would be helpful if you guys typed no for me. Oh, my screen is blurry now? Oh, it's good? Okay. I had it on full screen, that might be why. I'll just keep it like this. Okay, cool. But you guys have no questions so far? Okay. If you guys have no questions, then we're going to move on to using an example to kind of illustrate this. So let's say that we had an animal class. And an animal class serves as a very good base parent class to have subclasses for, because an animal is a very general term, whereas you can have a dog or a tiger or a cat or a horse, which is more specific. But a dog and a tiger and horse or any other kind of mammal, all of them are animals. So all of these three things, these subclasses, share a lot of the same attributes. So in terms of in computer science, one very good coding practice is reusability, so reusing code. And so having a larger animal class that you can then draw code from for these subclasses is very helpful, because then you're not rewriting all of these methods, sound and eat and run, multiple different times, when in fact all of these different classes, dog, tiger, and horse, are all just going to have those same methods. So it's helpful to just have one parent class animal that has a lot of attributes that you're going to have to share for smaller subclasses. And then in those subclasses, you can add on things such as a horse, a tiger, and a dog are all going to make different sounds, but they all still make a sound. And so we want to put that in our parent class. But then we can rewrite that method in our child class to better fit each individual subclass. And then, as you can see, some of our subclasses also have methods that are a little bit different from our superclass. So, for example, a dog can guard and a tiger can attack, but that is not true for every single animal. Does that all make sense so far? Okay, cool. So now I'm going to go into Eclipse and we're going to code this example to illustrate that for you guys. Okay. Can you guys see my Eclipse? Okay. So I've kind of started to outline a basic animal class here. And so just like we saw in that diagram, all animals are going to have a color and a pattern. And I also added a name attribute. And then we are going to say that all of our animals make a sound, they all eat, and they all run. So I just went in here and I filled in the eat method and the run method, and we can do the same thing for the sound method. So we can just say, so then if we just had a general animal, whenever we called one of these three methods, all of our animals would print out this same thing. But animal is pretty general, and so we are going to make three subclasses that are a little bit more specific, because animal is general and we want to create different types of subclasses to better represent each individual kind of animal. So in our diagram for the dog class, each dog, even though it's an animal, we can have it make a more specific sound than just saying that this animal made a sound. So dogs make a barking sound. So we could say that this animal barked. And so this is an example of a subclass taking a method that already exists in a parent class and overriding it to make it more specific. But then we can also add on more things into our subclass that our parent class cannot do. So for example, we had that guard method, so we could say public void guard. And then we can just say and then we can do the same thing for the type. Oh, and we also need to make a constructor. Oh. Okay, we're just going to go ahead and we're going to put this on a different file. I wonder if I'm in your private class, that'd be okay. No, okay. Okay, we're just going to put all of our classes in different files. So I'm just going to copy and paste this. Oh, and then whenever you create a subclass, you want to use the keyword extends, whatever the parent class is. Okay, did that fix our error? No. Okay, there we go. Okay, so now we're going to do the same thing for our tiger. So we're going to make a new tiger class. And then so our tiger, we said, was going to make a sound that was different from the general animal. So, and then we're going to name, I guess a tiger roars. Roared? Is that how you spell that? And then this is giving me an error because I haven't typed yet that tiger is going to extend our animal class. So right now, since Java doesn't know that, there is no name variable that exists. But once we add that extends animal keyword in, now Java knows that our tiger class is going to point back to our animal class. So all the attributes that are in animal, tiger is also going to receive. Okay, so now if we do our horse class, horses can also make a more specific. So we can say, and then if we go back to our tiger class, we also said that our tiger could have a more specific action of attacking. Okay, so now that we have all of our subclasses written, let's test it out in main. So first I'm just going to create one of each type of animal. So D equals new dog. Oh, we also need a constructor. That is very important. And we're going to have it take in 3 parameters for color, pattern, and name. We'll make color equal to C. And then name equal to N. And so something that you could do in your subclasses if you wanted is if you wanted your dog to have a more specific constructor than the constructor of animal, then you can go back and you can add in a constructor that will be more specific to your subclass. Um, okay. So we're just going to add constructors into our subclasses really fast. And so you can see here, I just had Java auto-generate constructors for us. And so Java is using here the keyword super. And basically what super means is whenever you see this, super is basically a another word for the parent class. So whenever you see super used in Java, that means that the class that you're currently in has a parent class, and we want to go back into that parent class and use their method. So for example, here we're in the dog constructor, and we see a call to super. So what Java is going to do, it's going to see this keyword, and so it's going to go back and it's going to look for animals constructor, and then it's going to call animals constructor using these 3 parameters. And so then the same thing is going to happen in tiger and horse. Okay, so let's make a new dog. And so our dog, we'll just call it dog. And then its color can be brown, and its pattern can be spots. And then we're also going to make, what's the difference between? We'll talk about that in a second, Lindsay. Okay, so we're just going to make a new tiger T and a horse H. Do horses really have a pattern? We'll just say the horse is striped. We'll just call it horse, and then tiger. I guess tigers also kind of have stripes. And our tiger can be orange. Okay, so we've now created 3 new objects. So let's see what happens if we call b.sound and then t, and then okay, so it looks like I forgot to put some spaces here, but you can see that when we called the sound method for each one of these objects, we didn't call the original sound method that was an animal. Instead, Java went straight to the more specific subclass method. And so then if we did, so our tiger had our attack method. So if we did t.attack, then that would print out exactly what we had in our attack method under tiger. But then if we try doing h.attack, you can see that that doesn't work because our horse class does not have an attack method. Even though tiger and horse are inherited from the same parent class, attack is a method that is specific to our tiger class. So this is something that the AP test might have you to do, is trace back if you have certain objects that have the same parent and they're calling methods, it might ask you which ones will work and which ones don't. And something that is very helpful is to draw an inheritance diagram, such as I showed you guys before we went into doing this coding exercise. And that can kind of help you to visually see exactly which classes inherit which methods and which classes only have methods that are specific to those subclasses. So h.attack is not going to work here. So now let's go back to Lindsay's question. She asked if we could declare something as an animal. So if we had animal A, let's say this is a dog object. And so we'll have a dog that is black. This dog. Also just got a dog. And then let's also make an animal here. Animal A equals new animal black. Okay, so if we have these two objects here that we just created, a dog and an animal. So basically what the difference between these two things are is that even though they're both declared as animals, dog is going to be pointing to a dog object, whereas our animal is just going to be pointing to an animal object. And so even though this first one, we want it to be a dog, since our dog class is a subclass of animal, technically our dog is an animal. So when we declare this new dog object, we can create it as an animal instead of as a dog. However, you cannot do this the other way around, where you would have dog D. This doesn't work. It has to be this way around. And then you can also just have our animal A equals new animal, where you just declare animal as a parent class object. And so to clarify this a little bit more, because this is something that is sometimes confusing for a lot of people, is when Java is running code, it basically does two checks. It does a check through the code at compile time. So when all the code is compiling, Java goes through and it checks line by line to make sure everything's okay. And then it goes back again, and when it's actually running the code at runtime, it sees whether everything is working or not. And so what it's going to do at compile time is when it gets to this line of code, it's going to see that we declared this object as an animal. However, it's not going to get instantiated until runtime. So right now, all we care about is the left side of the code. And so now what Java is going to check for throughout the code is that every time we reference our dog object, we just want to make sure that it is doing a method that is part of the animal class. So for example, we could have dog dot sound, because sound is part of the animal class. However, let's say that we did dog dot, what was our other method that we did? Dog.guard. You can see that when we do this, Java is giving us an error. And this is because even though we declared dog to be when the dog object is instantiated, it's going to become a dog. At compile time, Java doesn't know this. Java only sees the left side where we have made it an animal. And so when it is compiling and it's checking the code, when it gets down to this line, it's going to search for the guard method in the animal class, and it's not going to see it there. So Java is going to think that this is a mistake. So how you fix this is you can cast dog to be a dog object. And then did I do this wrong? Okay, there we go. Okay, so now you can see that we no longer have an error because we have cast our animal object to be a dog. So when Java goes through and it compiles this code, it's going to see that our dog variable has been cast to a dog variable. So, our dog variable is cast to the dog class. So then when Java goes looking to make sure that our object has this method, it's not going to look into the animal class anymore. It's going to see that we cast it to a dog, and it's going to look in the dog class and see that guard is there. And so now this is going to be okay, and both of these methods will work. Does that make sense? That concept is usually very tricky for people. I remember this was one of the hardest things for me to wrap my head around at first. And does that answer your question, Lindsay, or do you want me to clarify it a little bit further? Okay, great. So yeah, the main thing to remember is that Java is going to check the type of your object at compile time first. And so if you are using polymorphism and you want to call a child class method, you have to cast it in order to avoid a compile time error. Okay. So now let's just see if we just called dog.sound. So when we run this, we can see that even though, like I said, we declared dog as an animal object, and when Java is compiling its code, it's going to check to look for the sound method in our animal class. Once Java actually goes back and it runs this code, at runtime, we are going to look at the right side of this code, and dog is going to be instantiated into a dog object. So now at runtime, when we go and we try to find the sound method for dog, we are going to look at the more specific dog class to find the sound method instead of at the super animal class for its sound method. Does that make sense? Okay, great. I just have one more example from the textbook that I was going to show you guys to clarify this more, and then we're going to do some practice questions. Okay. Okay, so let's look at the shape class. This is the kind of thing that you will see more likely on the AP test, where things are called very similarly, and a lot of things have very ambiguous or abstract methods to try to confuse you. So here we have a shape class that just has one method, this what method, and in our parent shape class, it's going to just print out shape. But then we can see that we have these 4 subclasses that are all, well, this first rectangle class is extending shape. Then we have a square class that is extending our rectangle class. Then we have an oval class that is going to extend our shape class, and a circle class that is extending our oval, and they're all going to have this what method. So if we look at rectangle, its what method is going to print out rectangle. And since rectangle is a subclass of shape, it's going to override the what method of our shape class. Then we can see we have our square, which extends rectangle. So when square calls our what method, it's going to first look to its parent class, which is rectangle, and it's going to call its what method. However, if there wasn't a what method in our rectangle, then square would go and it would look at its grandparent class, which is shape, and it would call its what method. Then we have oval, which is going to extend shape again, and so it's going to call oval or print out oval whenever we call the what method. And we have a similar thing to our square method, or sorry, to our square class, where circle is going to extend oval, which extends shape. So our circle has shape as its grandparent class. But unlike our square, circle does have its own what method. So whenever we call circle.what, it's going to print out this first instead of looking at its parents' what method or its grandparents' what method. So if we look at this method, what is the output from running this? We're going to print out shape, rectangle, rectangle, circle, because we can see that we're creating this array of first a shape, then a rectangle, then a square, then a circle. So if we go through this and we run our what method for each thing in our array, first for shape, we're just going to look at our shape what method, which is just going to print out shape. Then we're going to go to our rectangle. So we look at our rectangle class, and our rectangle does have its own what method. So then we're going to print out rectangle. Then we're going to go to square. And like we talked about, we go to square. Square does not have its own what method. So we're going to go to its parent, which is rectangle. That does have a what method. So we're going to print out rectangle again. For arrays, doesn't every object in the array have to be the same type? Great question, Lindsay. So yes, all objects in an array do have to be the same type, but that is a cool thing that polymorphism or inheritance allows you to do, where all of these objects inherit from the shape class. So since our array is of shape objects, our array can hold any type of object that is that its parent class somewhere up its inheritance line is a shape. Does that make sense? And like we talked about last week, it's the same thing with interfaces, where you could also make an array of objects that all have a certain type of interface, which is a cool feature of Java. Okay, so back to this. So we said shape, rectangle, rectangle, and then circle. So then if we go to circle, circle has its own what method, so it is going to print out circle. So our final answer will be shape, rectangle, rectangle, circle. Does that make sense to you guys? Awesome. Okay, so now we're going to do some practice questions then. So let me send you guys the link to these. Okay, so I'm going to give you guys 15 minutes to do these questions. If you don't finish the coding part at the end, that's fine. Because on the AP test, you will most likely not have to write code dealing with inheritance. It's going to be more tricky multiple choice questions, such as the one that we just did. So try to concentrate first on the multiple choice questions on this practice test. Okay, I'm gonna give you guys 1 more minute to submit, and then we're gonna go over the questions. Okay, so now we're going to go over the answers to the questions. You guys did a pretty good job with this, so that is good because these multiple choice questions are pretty similar to what you would get on the AP exam. Okay, so for the very first one, we are looking to see what happens if we declare a new student object, S1. If we declare a new student object and then we try to do s1.getInfo. So as we talked about earlier, we're declaring the object as a student, but then when we go and instantiate it, we are making it a grad student object, which means that S1 is going to end up being the more specific grad student subclass of student. So when we go and try to call getInfo on S1, first we're going to look at the grad student class. And we see that grad student doesn't have a getInfo method. But we see that grad student does extend student. So then we're going to go and look at the student class. And we see that student does have a getInfo method. So we're going to go into its getInfo method, and we're returning this.getFood. So if you guys remember, this is just a keyword that means the current object. So when we call this.getFood, we are calling s1.getFood. And like we said earlier, S1 is a grad student object. So we're going to actually look at the grad students get food method, and that is going to print out taco. So the final answer for this question is going to be taco. Does that make sense, everyone? Great. So now let's move on to the next question. So it's asking which of the following statements will compile without error. So let's look at the first one, which is b.getISBN. So we're declaring book B to be instantiated as a dictionary object. So when we call b.getISBN, first we are going to look at our dictionary class to see if it has an ISBN method. it does not have a get ISBN method, but we see that dictionary extends book, and so we know that we're allowed to go up and look at the book class. And it does have a get ISBN method, so this code is going to compile. Now let's look at option 2. So if we say b.getDefinition, wonderful, then what is going to happen is when this code compiles, oh, actually, sorry, I should have probably explained this a little bit differently. Since we're just looking at compile time, what I said for you guys, I'm sorry about this, would actually be what is happening during runtime. During compile time, we're just going to see that B is a book, not that it gets instantiated to be a dictionary. So this first answer is still going to be correct, but when Java is looking at this code when it's compiling, it's going to just go and look straight at the book class because B hasn't been instantiated to be a dictionary yet. So sorry about that. That is a very easy mistake to make. As you can see, I just made it while going over this. So when we look at b.getDefinition for the second question, so B is still a book object at compile time. So when we go into the book class, we don't see a getDefinition method. It's only in our dictionary, but at compile time, B is not a dictionary object yet. It's just a book reference. And so this is not going to compile. However, if like in this next statement, we cast B to be a dictionary object, then Java is going to go check in the dictionary class during compile time. And it's going to see that we do have a getDefinition method. And so 1 and 3 are going to work fine. So our final answer is going to be D. Does that make sense to you guys? Sorry, I had that quick mix-up. Great. Okay, so for this code, I'm going to show you guys on Eclipse again. Okay, so here is the clock method, or the clock class. This class was pretty simple, so I just wrote the whole thing out for you guys. In our constructor, we're just going to make our hour instance variable equal to h, and our minutes instance variable equal to m. Then for get hour, we're just going to return our hour variable. For get minute, we're just going to return our minutes variable. And then for print time, we're going to print out the hour plus these 2 dots and minutes. So it looks like it is in a time format when you print it out. So is everybody okay with the clock class? Okay, so then let's go and let's write the alarm clock class. So since we want alarm clock to be a subclass of clock, we are going to write the keyword extends clock here. Okay, so first we had to write the constructor for alarm clock. We're going to have public alarm clock. And we had that our constructor was, we actually did not give you guys a parameter list for the constructor. So what we are going to do for our constructor is, since alarm clock is extending clock, we want to make sure that we set both these variables of the alarm clock class, but also our instance variables in our clock class, so our hours and our minutes. So in our constructor, we are going to want to have an int for the alarm hour, and also an int for our hour and our minutes variables in our clock class. So once we have our parameter list, like we did for our animal class, whenever you have instance variables in your parent class that you want to instantiate, we always want to start by calling super. And what this is going to do, like we talked about earlier, this is going to go to our parent class constructor, and it's going to fill all of this in. So our parent class constructor is taking in our parameters for the hour variable and for the minutes variable. So in super here, we're just going to input in H and M. So you always want to make sure, since this is technically just calling clock, like our parent clock constructor, you want to make sure that the number of parameters in this method and the number of parameters in this method are equal. So super H&M is going to call our clock constructor, and it's going to set these two instance variables. Then we want to still set our alarm hour and alarm minute that are specific to our child class. So we are going to say alarm hour and alarm minute equals alarm M. So does the constructor make sense to you guys so far? So we're just making sure that we first always call super, so that we call our parent class constructor and get all of those variables set. And then we are setting up whatever information we also need for our subclass. Okay, cool. So now we are going to override the clock type method. And we are going to talk more about this in next week's webinar, but I used this word earlier, and override is basically, it's a definition that you guys should know for the test, and like I said, we'll talk about it more next week. But whenever you override a method, that means that you are taking a method that is in your parent class. So here our clock type method, and we are going to be rewriting it in our subclass. So we want to, so in order to override a method, it has to have the exact same method signature as the parent class method. So we are going to do public void clock type, so that is exactly the same. And so instead of printing out normal clock, we are going to have our alarm clock method print out alarm clock. Then the last thing that we are going to implement is our set off alarm method. And so this is going to print out this statement if our clock time from our clock parent class is equal to our alarm time. So what we are going to want to do is first we have to get these two variables, our hours and our minutes, from our parent clock class. So what we're going to do is we are going to call super dot get hour, and then we can also get minute. And what these two things are going to do is, just like with our constructor, these two things are going to go to our parent class method, and they are going to call these methods. So it's going to return hour and minutes for us. And so what we are going to want to see is if super.getHour is equal to our alarm, and if super minute is equal, and if those two things are equal, then we want to print out all of this. So alarm is ringing. Those alarm is ringing, and then we wanted time. So at and then we can do the same thing again. We can do super. So actually, there are two ways that you could do this. So you could just call again super dot get hour plus, and then plus super. And this would be totally acceptable. Or what you could do is you could have two separate lines where you have alarm is ringing, and then all that we asked you to do was to print out alarm is ringing and then also what time it was. So we can see that in our clock class, we actually have a method that prints out the current time. So then we could just call super dot, and that would also be totally acceptable. Okay, so this is our finished class. So do you guys have any questions about this? I'll just give you guys another minute in case anybody's typing out a question. Okay, if no one has any other questions, then that is it for tonight's webinar. Thank you guys all for coming. Just a reminder that if you have any final questions before the AP exam in the next few weeks, you can sign up for one-on-one tutoring sessions with us. Or if you have simple questions, you can always just email us or send us a GroupMe message. And we have one final in-person meeting coming up in a couple of weeks, so make sure you RSVP for that. And our next webinar will be on either Wednesday or Thursday of this week, and it will be a repeat of what we did tonight. So if you want to go over everything again, then you are also welcome to come back to that webinar. So I hope you guys have a good week, and that is it for today. See you guys soon.